is one of the events that this system can react to. In the case of the garage door, it's one of the only events that it reacts to. And then a transition is specifically includes a state, an event, and the next state, given that combination of current state and event. Any questions about that so far? Yeah. Yes. So here's opened right here. And the way was that your question, opened? So the only way you can reach opened is if the door is opening and you reach the end. So maybe there's a sensor, I don't know how those work. Maybe there's like a load sensor, no idea. But somehow the system recognizes that the door has reached the end and sends that signal, and now our door is opened completely. Does that make sense? Any other questions about state machines? Cool. I think they're one of the easiest sort of computational models to understand. But let's go back for just a moment to the definition of a state machine. It's a model, so it's more than like a computer science concept. Eventually, it's mathematical. I'm not great at math or computer science. So this is sort of like proof that I think it's one of the most accessible, logical things that exist. But the key is it describes the behavior of a system that can only be in one state. And all you've got to remember is you've got a list of states, you've got some events you can throw at it, and your state machine is sort of the result of that state and its events. Yeah?
So when you're talking about transitions, does it have to be irreducible such that you're starting at the closed state, there's a transition, and you're ending at the opening state? But a transition couldn't also start from closed and then encompass stop will close, such that the transition kind of navigates through the two states?
I guess I haven't thought about it that way. So that would be, I guess, two transitions. A transition is sort of a pure function that says, given a state and an event, what's my next state? Yeah, the only thing I would correct with the term you just used is the button is not the transition, the button is the event. The transition is those three things combined. Terminology is pretty important in this case.
Thank you.
But yeah.
Does that run in parallel with something like event sourcing?
I don't know. I've heard the term event sourcing, but it's been probably 2 years, so I don't remember what that is, actually. So let's see what that looks like. I could open this browser to the /state machine component here, which will behave just like the component that I showed you, which was implemented with flags. It's not going to tell you much from at first glance because it just works. Oh, I forgot to show you. So we're sort of clicking outside of the modal, which is what I'm trying to do right now, does not close it anymore. Whoa, okay. I'm only allowed to go home. So this way you sort of, once you've sent that $10,000, you can't just do it again. You're directed to somewhere else. But let's look at the code for this one. If we scroll down to our markup, we've got sort of the same story here. Intro paragraph form, some inputs. And in our modal, we've got a notification, a couple of buttons. And actually, before we look at this too much longer, my favorite way of building a React component, well, building something using a state machine is to start with a graphic. My favorite tool for this is called Plant UML, which allows you to create UML diagrams using code. No mouse required. That's a separate talk. It's awesome. But I will actually sit down and create a diagram with product owners, designers, whatever. So we know exactly how we want this thing to work. So the first thing you can do is whip up a state machine diagram in 27 lines of Plant UML. So this is all sort of dynamically generated. If I get rid of this, let's say empty to sendable right here, you can see the graph re-renders. So it's a really great way to quickly whip up diagrams. So here's the state of my component. Instead of thinking about flags, these little flags that I imperatively read and set throughout the life cycle of my component, like you saw in the first implementation, I sit down and I think about the states that my component can be in. It starts empty if the user changes the input, so that is here. Then we're going to call this thing sendable. From sendable, we can go either back to empty, that's when I clear the input, or to a high amount. And that would be if I try to send too much. So if I go to 10,001, and I've already been told there's only $10,000 left, I'm now in the state called high amount. From high amount, I can either change my input again, or I can clear it. Get back to empty, get back to sendable. From sendable, I can fire off a send. I can send, and I will actually wind up in a nested state machine right here, which is the state for our modal that's got its own set of states and transitions, mostly to do with the API call and whether it's in progress, whether it failed, whether it succeeded. And you can really clearly see, to get back to sendable, for example, and close the modal, I can either cancel while confirmation is pending, or I can cancel after the API call failed. So you can see right away, if it's pending, I can't leave this modal. It's a very visual way to understand the behavior of your component. Any questions about the state machine for our robust send money component?
So is the state machine specific to React.js, or is it open for other?
No.
Available for other UA?
No, and I regret showing you this, this file first, because I meant to show you this first, to make it clear that it has nothing to do with JavaScript. Sorry about that. Nothing to do with programming, I guess. It's simply a description of the states a system could be in. It's quite abstract, and how a system moves from one state to another. So you'll find implementations for, you should be able to find implementations for whatever you're working in. And we'll get to that in a second too, the implementation. Yeah.
Do you use these diagrams with like the product owners to like
Yeah.
say this is to give them a clear view of what's happening?
Definitely, and I commit them to Git. If you didn't know what I meant by commit. Yeah, definitely. There's, like I said, it's another talk or I'll get too excited, but you can do any of the standard UML diagrams, flowcharts. The ones I use the most are state charts, like this one, and maybe like class diagrams, things like that. But flowcharts actually is probably the other one. So yeah.
I got a question for you.
Yeah, for sure.
Gustavo's asking online, he wants to know what the architecture looks like for an application, if there's just one state machine for an application, or if there's one state machine that manages other states, or what would that look like for an actual application?
Yeah, this gets into interesting territory. state machines, as I just mentioned, are an abstract concept. So if you sit down and look at the architecture of your app and realize this thing is a state machine, like we should delete all of our code and rewrite this whole thing using a state machine, that may be appropriate. I think AWS offers something, step something or other. Does anyone? Step functions, which allow you to do that, I think. Like you can basically, I think it's actually visual. I shouldn't say because I haven't used it, but I do know AWS does offer a product that would allow you to kind of create this, and then given a state, you can say, run this Lambda, for example. In this case, it's sort of a micro level state machine in that we're using it just for local UI component sort of interactivity state, but you can apply it to anything. Hope that answers the question. It can be a tiny UI microstate like this, or it can be used for the architecture of your app. Cool. So I hope as I babbled, some of you sort of let that sink in a little bit. And so yeah, big pro is that you can commit this. So right here, I've committed this file. It's going to live next to the actual source code. And now we get to talk about a library called XState, which I'm just going to talk about for a few seconds. You may have heard of this. It is, I think, becoming quite popular. But it's a JavaScript implementation of a state machine library. There is a distinction between a state machine and a state chart, also something I'm not going to get into. Check out XState, it's really awesome. But it allows you to define our state machine in JavaScript. Not going to get into the XState specifics, but check this out. We've got sort of a manifest of the various states that our system can be in. It can be empty, and on change input, this is the next state. Oops, sendable. If you look back, maybe you start with this diagram, and then you say, all right, let's take this thing and translate it into an XState machine config. And it really is just a list of states. So each of these keys inside of the state object is a current state. And then you give each one on. So you're sort of saying, given sendable, if I receive clear input, go to empty. We can go back here and say, given sendable, if I receive clear input, go back to empty. So we can define everything we just defined in that diagram right there in this simple object. And actually, you can open up the XState visualizer, which is an insanely cool tool. Paste this code in. Say update, and it will render your code for you. So maybe you build it in here. If you're building in JavaScript and you know you're using XState, maybe you skip that UML step and just build it here. One downside of the UML is that as soon as you change this, JavaScript, this is the source of truth. You got to remember to go back and change the UML. Haven't solved that yet. So now let's look at our source code. Oops, using a state machine. Back to our markup here. It looks, okay. It looks pretty similar to what we've seen so far. We've got some event handlers, and we'll look at those in a second. Here's our first sort of indication that things are different. Instead of checking flags to determine whether to disable our send button, we check what is the current state. and we can look back at our chart and determine, well, we want this send button to be disabled either if the input is empty or the user has entered too much money, more than is remaining on this job. But in this case, we don't even care, like, is the input empty? We're actually describing an entire state that this component can be in and calling it empty. So it's less of a, this kind of still looks like we're reading a flag, but we're actually reading the state of the component. State.matches is specific to the XState React library, by the way. And here's our other sort of first indication that something is different. When our modal fires a close event, in our listener, instead of having a handle modal cancel function, which is a very common React pattern, so let me put these side by side. Which, of course, we can go to and see that it's defined here in our component, and it checks and sets some flags. We can actually just tell our state machine, cancel. That's a little weird. It's like there's not much context there. You're just saying cancel. But if you look at our chart, cancel doesn't need context. Like, we don't need to say modal cancel, for example, or cancel button. It doesn't matter. All we know is that if the confirmation is pending right now and we get a cancel event, we're going to go back to sendable. So we're going to close the modal and go back to where we were before. So if you fire a cancel at a place where it doesn't make sense, like let's say we're empty right now, and we fire off a cancel event, the state machine says, and if we look at our config, we can confirm this. The empty state reacts to change input. That's all. So we can fire off any sort of event at it that we want, and the state of our machine is not going to change. So we don't really need extra context when we fire off an event or we throw an event at our machine. The context is in the current state. So we got rid of an entire event handler. We just tell the state machine, cancel. Same thing, I believe, down here. We had a yes and a no button. We just say, cancel. What's another interesting? Let's look at the form handler. On submit, handle send. And then let's look at it in flag land. So here we checked the amount. We set some flags because we're currently sort of in the middle of something. We maybe return early. We send some other flags in that other branch like I mentioned before. Here we just send the state machine a couple of events. If they requested too much, we say, they tried to send too much. Or else we can just say send. And we look back at our chart and we know that send is going to, well, actually, we sort of don't really care what state we're currently in, but it's clear in this chart here that if we're sendable and we get a send event, now we're going into our modal nested state. This black dot, by the way, is indicating the initial state. So every time we enter this nested modal state, we're going to be confirmation pending. And then the final method let's look at our handle modal confirm. And this is when, just as a quick reminder, I've entered an amount, and I've confirmed that I want to send the money. That's our modal confirm. So in flag land, we set some flags. We try our API call. We set some other flags. And at the end, we clean up and set some other flags. With our state machine, we just send these simple events, make our call, send success or failure, and let the state machine determine what to do next. I think there's one more. Oh, handle input change. So this is a fun one. As the user types in this input here, to get it to the button to disable when it goes back to 0, and to show an error if there's too much requested. In flag land, we do a bunch of imperative flag setting. Let's see what happens here. We set our amount, which is sort of a piece of state that's separate from the machine. And we fire off a couple of events at our state machine. And we let it determine the state of the entire component. Any questions?
So if I have a child component that has its own internal state machine, am I sending events to that internal state machine of that child component? Rather than having, it's like normally in React, you just have local state with like hooks or whatever, you send data down and events up. Am I sending events down now?
In this case, there really isn't a child component, right? All of this is in one component. So
If I had like a really large, complex application and I want to have local state within various components, you wouldn't do that with this. You only have one state machine for the entire application. You would never have distributed states for different components.
no, I think you would. So in this case, the state machine is as high as it needs to be. It's as high as the send money component, right? So actually, you could look at, maybe you started with just the modal right here, and then realized, actually, we've sort of got some state above that, which is the input and the send button that sort of trigger the modal, and you move your shared state up one layer, just like you're sort of taught in React from day one. But if this component is living in an application, the state machine that we're looking at right here is still only local to the send money component itself. It's not moved up to the app. So if I've got other UI components on that dashboard, for example, maybe there's like a current balance. The current balance doesn't know anything about this state machine. The dashboard doesn't know anything about it. If you find that your dashboard is a state machine, maybe it would have its own, but this state machine will stay as close down to its component as necessary. Does that answer your question?
Yeah.
There was another one?
Are you initializing your state and set the how do you initialize your state machines?
Yeah. I think in this case, let's take a look. That's where it gets into XState, which I think is kind of its own talk. Let's see. XState React, which you'll see right here, provides a useMachine hook. You call useMachine, which returns, well, you give it a state machine, which we can look at, is the thing I described right here. And it is a machine defined, it's an XState machine object. So useMachine returns the state and a function to send an event to that machine. So that's how it's initialized in this case. So this is specific to XState React.
state, like, based on something in progress.
Yeah.
In that case.
XState React actually does account for that and allow you to sort of hydrate it based on, something else. In this case, we just started at the declared initial state, which up here is empty. But yeah, you can do that. I think there was one more.
I was just curious about testing, like how do you run into it? And it just seemed a little funky to me, the set event function, just like how do you run into unit testing, how do you just like study that out, not worrying about it?
That's actually something. So you could test the state machine easily with unit tests, because obviously this right here is a super simple pure JavaScript object that doesn't know anything about UI. And I guess you could say, given state X, if I send event Y, I should see state Z. At that point, you'd kind of be testing XState, though. I don't know how useful that would be.
I was just wondering if you run into it at all.
Yeah, I guess the short answer is I've not tested this, which is another story. I don't want to get into that. I left out some parts of this week at work. Yeah.
Can we go back to the state diagram?
Yeah.
I'm really enjoying this, but my question has to do with, are there naming standards in the sort of finite state community? Because I'm having a little trouble with a name called Sendable. But I'm not, and I've been trying for the past couple minutes to come up with good alternatives, but I can't. Because Sendable to me, the trouble I'm having with it is if you issue the send event, then that implies that all validations are complete. But yet in that same state, you also have the validation that results in one possible outcome is that it's too much.
Yeah.
So sendable to me really says this is ready to go unconditionally, but yet you have that conditional check packed into it.
Yeah, that's actually something I wanted to clean up. And I actually think that maybe if your state name doesn't make sense, it may mean that your state machine doesn't make sense.
I also wondered about that too, is how do you handle multiple outputs? Because that tells me that there's some, that sendable within it perhaps has some inner state.
Yeah.
Because of amount, right?
Yep.
The
Yeah.
The path that sendable takes, or the valid transition depends on a flag, if you will.
Yeah.
So maybe is that a theoretical issue that on one hand it sounds like you've transformed all use of flags to this finite state machine, yet you do still have states with embedded flags in them.
Yeah, absolutely. That is something I struggled with as well, and didn't actually end up finding the solution. There is XState supports. You saw in the docs a second ago, it said state machines and state charts. State charts is like an extension of state machines that include things like context, which would, ideally, I would like to move out of this UI component the networking and the amount, and move those into the state machine so that the UI can just say, what state am I in? And also send events back to the state machine. But the machine can keep track of those other contextual, purely logical pieces of data. And one of the things context support, one of the reasons it exists, I think would be for the use case of moving the amount in there. And it got a little complex when I got into that. So I ended up taking it out. There it is. So this would be definitely something to look into. And I also do think that your suspicion that my state machine might not be the best Probably correct.
Where's that where's that transition that you're talking about in code? I missed that. I think you showed it. I missed it. Where it transitions.
Where it sends too much.
Yeah.
Yeah, it's a conditional when the
Set amount, right?
when the send button is clicked.
That can't be right because the send button is not clickable if your number is out of range. Is it?
It becomes clickable again when the input changes, because the first thing that happens when the input changes is a clear or a change, in which case you'll go back to another state that makes it clickable.
So you can click it with an out of range number, even though it's not valid. I thought it was clear. Maybe I misunderstood that.
Yes, yeah, you can. Sorry.
Oh, okay.
Yeah,
And that's by design.
it is by design. Yeah,
Oh.
And that's
maybe not a great design.
That suggests to me that you have your state machine highly coupled to your UI, because
Yeah.
you have several flavors of invalid input here,
Yeah,
and you're checking for them in different states. The first, well, one level, you're allowing probably the HTML itself to handle that it can only be a number, right?
yeah, that's sort of offloaded to another.
Right. And then you're offloading the negative check for a dollar amount, right?
Yeah,
And then the zero check is handled by the state between, what is it, empty, or it's not called populated, but empty versus sendable.
yeah.
And then the out of bounds, well, then that raises a highly theoretical question: is nothing out of bounds? Is zero out of bounds? In Word, you're calling it empty, but only when you trigger. So you're handling zero differently. So that out of bounds in one direction, you're handling differently from out of bounds in the other, and that's really coupled to the UI. Is that what you're objecting to, Jay?
No, I have no objection.
Well, not objecting, but like observing.
Yeah. I might look at
how
the-
something was working related to your other question. That's all.
Yeah, I might look at this nested state machine as cleaner. I think it is, and I think it's sort of evidenced by the fact that these event handlers simply send an event back to the state machine. I think this may be a little bit of a red flag. If you have to do some logic in here, I think there may be some work to do. But I think the modal state machine itself is cleaner.
So there's a send event function that's being called. Where's that defined?
That's that's a piece of the React, the XState React API. So when you say, I want to use this machine, it gives you back the current state and a function to send an event to your state machine.
But that's being used on that instance of the state machine.
Yes. Yeah, and this is the API for XState React. Yeah,
Sorry.
no worries.
Thank you for answering those questions.
Oh yeah.
Yeah.
Oh yeah, I should say before you go on, I'm not an expert in state machines, obviously. So I wanted to make it clear that this talk was about moving a component from flags to state machine, which is maybe not the final destination, but was definitely a step in the right direction. Go ahead.
So it looked like in some of the, when you're changing some of the states, you were sending events and you were pre-pending the event with modal dot.
Yeah.
So what's going on there? It doesn't know what state it's in, so you're specifying it, or is that just like a more verbose way to?
Well, that's one of the states.
That's like a
If
child
you look at
state.
state machine, it doesn't say.
You can send it. This is actually something I've been wondering, because if you check, no, this makes sense. If I check the state, I'm sort of checking the current state, that is. I'm checking the parent and child state. So there's my modal.api call pending. So that's saying if we're in modal and API call pending. Is there another?
How's that represented in the object when the state object is created?
So all the sends do not use that dot notation. In the config definition for the state machine, I've got a list of states. We've got empty, high amount, sendable. And then modal is itself its own config, so it's nested. It's got its own states right here. And so cancel refers to, for example, the parent state.
If you also were to have put like the amount in the state machine as well, that would be another nested state machine. So in addition to mobile being a state machine, you have another one for the amount.
The amount, I think, would be context.
Because that's the infinite part, right?
Yeah.
That can be any number.
Exactly, and that's exactly what this says here. When finite states are well-defined, states that represent quantitative data can potentially lead to infinite state. And that allows you to move more logic out of your UI and into your sort of calculator. The XState shows the example of a glass of water which knows how much it's filled. I wanted to get that into the talk, but first of all, it made the code much more complex, and I wanted to keep it simple as far as just an intro to state machines. There's a lot. Hopefully, if your appetite is whetted, definitely check out XState for all the state chart goodness. It's got great docs. It's a lot of fun. Cool visualizer too, obviously. This is really awesome. Any other questions?
You unambiguously supporting state machines, or you feel like there's an inflection point, like simple components to whatever flags,
Okay.
like the configuration
Oh.
costs too much.
That's a good question. I haven't come up with a rule of thumb yet. The one I sort of initially came up with is that flags may be red flags. And I just found that when I refactored a couple of components to use state machines, instead of a whole bag of flags, they became more robust. When it came to changing requirements, it was much easier. You could just throw a different event at it instead of the danger of forgetting to read or set a flag somewhere in the midst of that already happening 5 times in each conditional branch. So I guess so far, again, not an expert. I've done this less than I can count on one hand, right? When flags start looking like red flags, I think it's time for a state machine. But if you try to draw the chart and it's not working out, it may be the wrong model. That's also another talk, right? There was one more? Yeah.
This is a bit of a React ecosystem specific question, but I feel like it's probably inevitable in this, is if you compare, like XState, I'm asking for your opinion on your experience basically, compared to like Redux, which is often compared to a state machine because it's capable of being a state machine but doesn't enforce it. I'm wondering, at the point that you got to there where you're starting to add context and so forth, those are things that kind of in the Redux reducer concept, you're always kind of handling that. You're telling it how to get to the next state. I don't know if you've used Redux, but I'm wondering if you had any comparison for the experience of where something like XState in a pure state machine is a better experience or a worse experience versus other methods of managing state besides just pure flags?
Mhm. That is the question that I expected to be first. Came much later than I expected. So I guess the question is, what about Redux, right? In my limited experience, I think Redux is for global app state. And you may use a state machine model for your global app state. But in this case, the state of this send money component isn't shared with anything else. It's not shared across the app. It's purely to define the interactivity logic of this component. So I guess so far in my mind, the distinction is global app state is something like Redux or whatever people are using now that everyone hates Redux, or a state machine if you can model the component using a state machine, but its state isn't shared with other components in your app.
You can just as easily make flags in Redux, right? So just because you're using Redux doesn't necessarily mean you end up with a state machine. I guess it puts the onus on you as the developer to make the state machine, make sure you don't have
Yeah, that's a great point.
invalid transitions or whatever, right? It
Yeah.
seems like the XState, like that's the benefit to me is that you can only be in valid states and you can't make invalid transitions, right?
Yeah, that's a great point. So it has more to do with how are you thinking about the state of your system. Are you thinking about its states, its finite states, or are you thinking about a whole bunch of flags and what they mean, and it sort of implicitly? Yeah.
So that question, or that answer, I guess, maybe you can do this question. Have you considered not using a library like XState and writing the states yourself? And have you considered possibly doing it with something like TypeScript, where each state could be a specific type and you're type safe around what transitions are allowed?
Yeah, absolutely. And I did that before.
That's how I was doing it. Wow, that's great.
Because yeah, if you look at
That was the same road I was going down. I was like,
it's a bunch of strings, right?
It's like, okay.
Yep.
And the way I wrote this first was more like this. So API call failed. So there's JavaScript. Obviously, you could get something similar with TypeScript. I reverted it because it was just much easier to read for the purposes of the talk. Yeah, you can easily implement a state machine. Using a couple of lines of code. If you think of a state machine as a sort of object that can be initialized and then can return a next state given a current one. I guess if that's all you need, yeah, you could use something like this, implement it yourself instead of using XState. So that is the answer to your first question. I think once you start getting into the totally awesome features that XState supports, which are in state chart territory, as opposed to state machine territory, which include things like nested state machines, context, any of the stuff listed on this sidebar, then I'd probably reach for XState. And yeah, as far as typing, I would definitely want to, I think, enumerate all of your states and events. In fact, I think I did that here. Yeah, so I like to do this. And actually, this is a event. So yeah, in production, I would absolutely do this, so that as soon as you start typing, state.foo, it doesn't let you do that. For the purposes of the talk, strings are best. This was just a little harder to read. Anything else? Nice. Thank you so much, everyone, for sticking it through. Thanks for all the great questions. I'll just leave this up in the background in case you forgot.
Awesome.
And
well,
thank you.
Yeah, thanks for coming out. And are you going to be hanging out with us a little bit
Yeah,
afterwards?
sure.
All right, so if you have questions for Patrick, you can ask either now for a little bit, or we're going to head to MASH, and we can all hang out there. Thanks, everyone, for coming, and we'll see you hopefully next month. Thanks. To turn on lights.
Patrick,
Yeah.
do you know of any sample applications or larger applications? That's something that you can do? Or sample?
I don't. Like getting back to the architectural stuff, like something that's built architecturally as a state machine. I would guess that I think AWS does a good job with their services of like providing samples.
Absolutely.
That would be the first place I would. So I feel like they'd come up with a good use case.
Well, that's what I heard. I'm actually back there.
That step function thing.
Like 4 years ago.
Actually, I don't know.